Start.
The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody, and welcome along to the DBA Fundamentals for this second session in October. My name is Warwick Rudd, and I'm your host again for today's session. In today's session, we've got Manohar Punna talking to us about cloud infrastructure as code with Terraform. I'll hand over to Manohar very shortly, but before I do have a couple of housekeeping slides to run through. First of all, this session is being recorded and will be made available on the DBA Fundamentals archive site after this session has completed. I am monitoring this session, so feel free to ask your questions throughout the session, and we'll get Manohar to answer those throughout. First off, a big call out to our sponsors. Without our sponsors, it makes it difficult for us to put these sessions on for everybody to participate in. Our first call out is to SentryOne. For those of you who haven't already gone to SentryOne's website, make sure you do. They have some fantastic free materials that you can download to help you along your learning path and also help you from your day-to-day activities as a data professional. Our second sponsor, DB Watch, they also have, like SentryOne, some fantastic materials that you can also download to assist you with your day-to-day activities and general data platform learnings. Just like this virtual chapter, there are many other virtual chapters available for you in PASS for you to diversify and learn different things in your environment. Have a look at the ones which are on the screen at the moment. Go to PASS, register for those particular virtual groups that are of interest to you. You'll get the notifications of when sessions just like this one are made available, where you can join, learn, rewatch those videos at any point in time. So with that, I'll hand over to Manohar to get this session going.
Thanks, Warwick. Start share my screen. All right, good morning, good afternoon, good evening, depending on where you're joining from. Today I'll be delivering the section on cloud infrastructure as code with Terraform. I'll be basically covering the concepts of Terraform and taking you through a quick demo on how we can use Terraform to build resources on Azure. I'll be specifically concentrating on creating SQL Server resources, but basically the concept is same whether it's SQL Server or any other resource on Azure. Sorry about that. A bit about myself. I'm Manohar Punna. For those who don't know me, I data platform MVP, community enthusiast. I deliver sessions at various events and blog a little. There's a lot of information on this slide about me. You can go through that once the recording is available, or and also I'll upload the slide deck. The most important thing on this slide is my Twitter handle at the bottom, Manu SQL Geek. So that's the easiest way to reach me. If you have any questions after this session or anything related to data platform on Azure. So as I said, I'll be covering the basic concepts of Terraform, why Terraform, what's infrastructure as code, what are the DevOps principles that drive automation, and we'll be looking at the Terraform demo at the end to show you how simple it is and how quickly you can actually get started with infrastructure as code using Terraform. So we'll start with DevOps principles. They are basically the 4 pillars of DevOps: the culture, automation, measurement, and sharing. The culture is mostly to do with the users and the organization and the processes around it. Automation bit is mostly the technical part where you use the tools that will help you achieve the DevOps practice or mature your DevOps practice. The measurement is basically how you measure where you are in terms of DevOps maturity, and the sharing bit is how you can write reusable codes that you can share across your organization. So today we'll be looking at the automation bit. That's where your infrastructure as code fits in. Automate everything, right? So that's how the principles are at this point. Anything that has to do that has to be done manually has got very good chances that that can go wrong. With automation, there is a defined process. Robotic processes do what they are told to do. So it's very important that you put in the right testing framework around your automation so that anything that you're automating is not doing the wrong thing repeatedly. Version control, of course, you want to track all the changes that's going in. This also helps in auditing purposes, and also make sure that you have got the right compliance in place and looking at the history if you have done something wrong, which has put you in a position that's resulting in some issues today. The CI/CD pipelines are actually the continuous integration and continuous development and deployment processes. So that's what will drive. There are tools like the pipelines, Azure DevOps, and other DevOps tools that will help you achieve this as well. And the things that will drive all of these, like how do you automate everything, how do you version control that code which you're automating, and how do you use that to control your continuous integration and deployment, is all based on code, right? And when it comes to infrastructure with cloud, it's very important that you deploy even your infrastructure as code. Everything can be controlled and built with the code. It's not like your on-prem infrastructure where you actually have to put an order and procure and stand up your hardware. Everything is managed by your cloud provider, and all you need to do is stand up the resources. Just issue a command asking for standing up a specific resource, and that's how you do it with the modern environments, especially in the cloud world. So with infrastructure as code, Terraform is one of the tools that will help you code or config your infrastructure. It helps you in building, changing, and versioning your infrastructure. So this actually helps you build your infrastructure in an agile practice. So you don't have to actually stand up all of your hardware at the start of your project. You can follow your agile principles and build only the components that you require. And everything is done using Terraform configuration language. It's a high-level configuration syntax that is used in Terraform. So and it lets you actually plan your execution, and it also builds a resource graph. So it knows what is the dependency between different resources, and that can be controlled inside Terraform. You define that in your HCL language that you write for your Terraform. Each cloud provider has got their own infrastructure as code solution. Like for Azure, there's ARM templates, Azure Resource Manager templates that you can use. For AWS, there's CloudFormation. So Terraform is a vendor agnostic or cloud agnostic tool. So this allows you to actually build your infrastructure not just on one platform, but on multiple cloud providers. You still need to change the code, but it's a single solution that you can use or single tool that you can use to build infrastructure across multiple cloud environments. And all of that can be built in one single repository as a massive infrastructure project, or you can modularize it and use different providers to deploy your modules onto different environments or different resources on different cloud providers. What Terraform ensures is the consistency across your infrastructure. It's a plugin based model. That means whichever provider you want to use, you can actually just use that provider. You just provide a syntax to a code block to actually define what provider you want to use. And using that provider, you just create the resource in it. Like for Azure, If you want to create a resource on Azure, there's an Azure RM provider. If you want to query anything on your Azure AD, there is an Azure AD provider. So similarly, there are providers for AWS and Google Cloud as well, GCP as well. And the changes that you deploy with Terraform is incremental. So you don't have to actually write your Delta changes. You actually just make the change to your code. It's similar to your SQL database project, where it compares the existing infrastructure and make sure it only deploys the incremental changes that you're deploying, or only the changes that you're pushing in. It also lets you actually preview the changes. That means it will show you an execution plan before it executes your infrastructure code. And it's scalable, given that it has got this modular functionality, so it's easy to scale up your Terraform, your infrastructure using Terraform. So I'll go through the basic concepts of Terraform. It's got variables, of course. Any programming language or any language that you want to use generally have variables to define your variables, so that you can reuse the same bit of code with different variables. It gives you an output. So when you're creating a resource, there are some parameters or attributes that you want to retrieve once the resource is created, like the resource ID. Right. So this is assigned by Azure, Azure Resource Manager. So you want to get those output when your resource is created. There are providers. So there are different providers, and you can write your own provider as well. There's an open source project, and there's also something which is supported by HashiCorp. So if you want to write your own custom provider, you can just open source. Because it's open source, you can actually contribute and write your own providers. The modules helps you actually define code for specific resources and reuse that across your different projects. There's a plan phase in Terraform. So basically, you can actually see what changes will be deployed before you actually run your code. There's an apply phase, which is your execution of your code itself, which is nothing but creating the resources on the cloud provider. The state file is the one which helps you actually maintain the state of your resources. So it knows what the state of the resource should be based on that state file. And if you manually go and change something on your resource, it knows that the state is not correct. So it will revert it back to the actual state file. What this ensures is you have got a consistency across your resources. You're controlling manual changes as well, and make sure that your code is actually consistent with your your infrastructure is actually consistent with your code. So no changes should be done manually. Everything should be done through Terraform. And the last bit is, like, when you want to get rid of your resources, there's a destroy command. So based on the state file, whatever resource you have created, it knows they exist, and it actually destroys them. And when it destroys them, it actually follows a specific logic. All the dependent resources will be deleted after the dependency is cleared. So if you have got a SQL Server and SQL database, the database will be deleted first, and then the SQL Server, and then the resource group in which the SQL Server is deployed. So all that resource graph is maintained inside that state file. So that makes it easier for Terraform to actually understand the dependencies and delete them in order. So I'll quickly go through these slides. This is explaining what was in these Terraform concept slide. So variables, as I've said, they are the inputs, and it has got type constraints as well. So you can restrict what type of data you're passing in, or what variables data type should be. It could be like simple data types like string, number, and Boolean. And you can have type constructs as well, like a list of string or a map or an object as well. And you can define it as a configuration language in your code itself. You can also pass it in as a JSON string or as a command line argument as well. The provider's definition, the providers contain the definition of your resource types. So this is what Terraform provides. You can use from the open source providers, or you can write your own providers if you want. And the configuration they have got their own configuration. Like some of them require a version number to be specified. So it all depends on what is the provider that you're using. and they must be initialized. So what happens is when you initialize, the provider is actually downloaded or onto the machine where it's running. So like if you're using DevOps, it's on the compute resources. If you're running from local machine, it's on your local drive. And when it initializes, it needs to know what the provider version is, and you can have multiple provider instances. So that's where you can say you can have a massive infrastructure project which will deploy resources across your cloud platforms like AWS and Azure at the same time. So modules are like, a container for multiple resources. So what you can do is like all SQL related resources can be clubbed into one single module, and say you just pass the parameters that is required for that specific module, and it creates all your SQL Server, SQL database, and all the resources that you define in your module. And at least one root module should exist. So with Terraform, you just specify Terraform init, plan, or run, 3 main commands in Terraform. So when you do a plan or run, plan or apply, it just picks the files, and based on the file definition, it will run. So at least one root module need to exist to run your Terraform code. And modules also helps you keep your code dry. So this is the principle in development practice, like do not repeat yourself. So if you are writing some code and if you have to repeat it at somewhere else, you actually make it into a reusable component. So that's where modules come into play. So if you want to create 10 SQL databases in a SQL Server, don't create a 10 SQL database resources. You actually create a module for your SQL database and just pass in the parameter and call it 10 times. It's a general principle in development. There's also another thing called as another layer on top of Terraform. It's called TerraGrunt. That will actually helps you in keeping your code dry. We will not be looking at TerraGrunt today, so that's another layer on top of Terraform that you can use. So Terraform Plan lets you see the changes that you're going to deploy to your infrastructure. It's like an execution plan. Before it executes, it creates a map of changes that it is going to deploy. Like if you've got a SQL Server and there's 3 databases on it and you're creating a 4th database, when you run Terraform Plan, it will show that only 1 database would be created, the additional database that you're adding. So if you're doing something wrong and if you're going to break something, like you're going to drop a database because of a breaking change, you would see that before in the plan itself, rather than directly applying and deleting the database accidentally. And apply is like execute. So it basically deploys the changes based on the plan. You don't have to run the plan always, because apply includes plan implicitly. So it actually creates a plan and shows you the plan and deploys the plan. A state file lets you know the state of the current resources. So it saves the state of the current resource. That means all the attributes, what is the state of that resource and all of that. And it also helps in creating mapping between the resources and dependencies. Plan and apply, when they run, they actually use the state file to compare it with the actual resources and see what are the changes that is deployed, what are the changes that needs to be deployed, or if something has changed, how do you revert it back? So all of that is dependent on the state file. And destroy, finally, like once you, because it's cloud, you don't have to like buy hardware and keep it forever, even when you're not using it. So destroy is a simple command that ensures that you actually destroy your resources. So you can have something like a transient resources, like compute for your maybe integration runtime and those kind of things. You can create the VM in the morning and then destroy it in the evening, right? So there's nothing that's saved on that compute. It's just like maybe Azure functions or something that's using that compute. So there's no data saved on those resources, and you create them when you need it and destroy them once it's done, probably in a testing scenario. So you've got your development environment where your developers are working. So you want to test it. So in your CI/CD pipeline, you create the resources that you want, like your SQL database, deploy your, get a copy of prod, deploy your changes, make sure everything is working fine, and then just destroy that SQL database, right? So those kind of things can be done very easily with code. Otherwise, you have to manually manage it somehow or use some other coding platform to do that. So Terraform makes it really, really easy to create and destroy resources. And you can also plan a destroy. That means you can see what will be destroyed when you run the destroy command. So we'll jump into the demo. I see there are no questions. So we haven't seen much inside Terraform. So I guess once we see what's inside Terraform, there'll be questions. So we'll be looking at a simple single module, like a massive infrastructure project that I was telling about. And we'll look at how you can actually modularize that same project into creating modules and how you use the modules so that you can reuse the modules as well. And we'll look at some complex variables that will help you achieve like how to keep your code dry and those kind of things. And all the demo that I'm showing today is actually available on GitHub. So you can download and start with the basic structure. So it's very basic concepts in your in Terraform, how to get started with that. So I'll be switching to Visual Studio Code. And all you need is you need to install Terraform. And if you are integrating with Git, basically Git repository or something like that, or Git, any Git tool that you want to use. In the terminal, I'll just make sure that I'm still connected to my Azure account. Yep, all good there. So before I start, I'll be, as I've said, like I'll be demonstrating two different use cases. So all-in-one, which is like a massive project. Modules where I've split that project into different modules. So in all-in-one, every Terraform code needs a main.tf. That's your main Terraform file where all your resources will be created. And there is a variables.tf that can be used to define your variables and pass in the variables as well. And there are other files that you can define, that you can create to pass in your variables. Like you can set configuration, like environment configuration. So let's start with main. As I've said, like you can use multiple providers in Terraform. So in this case, I'm actually using Azure RM provider. I'll just see if I can zoom in a bit. Yeah. So we definitely need to provide two blocks. That's minimum required. So the Terraform block and the provider block. So provider block tells which provider to use. So Azure RM is one of the providers, and I say use the version 2.2. I'm not defining any features block there. And for Terraform, in the Terraform block, I just say what is the required providers. At least one required providers needs to be specified here. And it ensures that I'm getting the right provider. And from there on, it's just the definition of the resource. And if you see the definition of the resource, it's very straightforward. When you compare this with an ARM template, I can quickly show if I've got an ARM template. Yeah. So this is your ARM template. So this code that I'm showing here is the code that is required to create all the resources that I have got in my all-in-one project here. And if you see in here, I've got 54 lines of code. The same thing in an ARM template has got 743 lines of code. And this template is basically, extract from the Azure portal. So let me switch back here. So in here, I'm creating a resource group. I'm creating a SQL server, a storage account to save my audit logs, and then creating a SQL database. So that's a very basic definition of your resources. So for creating a resource group, you just say what type of resource it is, you give it a name to reference, and then you provide the required configuration values that you need to pass. So for creating a resource group, you need to specify what the name of the resource group would be, and the location where it will be created. And when you create a SQL server, you need to provide the name for your SQL server, the resource group in which it should be deployed, the location, of course, the version of the SQL server, the administrator login and password. And you can specify the tags. So these are like, in your Azure, any resource, you can specify a any resource or resource group, you can specify a tag. And then I'm creating a storage account as well. Again, I'm passing the same required values, that is minimum required parameters that it needs, like the name, resource group, location, the account tier, and the replication type. I'm reusing the tags variable here. So this is deployed for one single project in this case. So I'm just using that. And if you see the definition of the way I'm using the variables, I'm just using the syntax like where dot. That means it will pick up the where dot the variable name from the variables.tf file. And this is very standard, like main and variables is defaults. So you can, even if you don't provide variables, you can't use like any variables if you're not using any variables in your main.tf, you don't have to create this file at all. So that's how you use variables. And in here, if you observe, where is one of them? The other one that I'm using here is, in this case, look at this Azure RM resource group that I'm passing as a resource group value for my SQL Server resource. And I'm actually referencing this resource. So Azure RM resource group dot example. So the name of that, the resource type and the name of the resource, the reference name. And I'm passing the name value. Yeah. So what this does is actually creates a dependency on this resource. So until and unless this resource is created, it will not try to create my SQL Server resource. So indirectly, I'm creating a dependency on the resource. Similarly, I used the same logic to, when I'm creating SQL database, I'm using the same logic to create a dependency on the resource group, create a dependency on the SQL Server, and create a dependency on the storage account. So without creating a SQL Server and storage account, I can't create my SQL database. And there is a chain of dependency here. So I've got a resource group, SQL Server, storage account, and a database. So if my SQL Server and storage account depend on resource group, I don't have to mention it as a dependency here. I can just say variable, like here, where.resource group name. I can use the same variable name. Because it got dependency on storage account on SQL Server, it will anyway depend on my resource group. So enough talking, let's look at how we run this. So first I need to do a Terraform init. So when I do init, you can observe here that it's actually downloading the plugin for my provider. And it says it's actually downloading the Azure RM provider and specifies the version. So this is coming from the block that I've mentioned here, the provider. And it actually creates a temporary folder here, which has got the plugin, nothing but the Terraform Azure RM plugin, right? So once this is set up, then I can say Terraform init, plan. So plan as if, sorry, this is going to break, sorry. I need to provide a TFRs. I forgot to mention one more thing. So I've defined my variables here, like the variable resource group name, location, SQL Server name, and all of this. And I need to pass these variables. So instead of passing it in command line, like here, it was asking for my SQL Server login, enter the value for password, right? So if I don't provide a variable file, a definition of my variables or values for my variables, it will ask for each variable that I've defined. Instead of that, what I'll do is actually save the values in a file called tfvars. And in this, I'm actually providing the values for my variables. And I'm going to use these values as an input to my Terraform plan. So I'll just go here and say Terraform plan, but I'll say .var file. So my var file is defined in my dev.tfvars. It's dev. So it now reads the values from my dev.tfrs file. So you can observe here that my dev resource group is tf dev RG. Location is Australia East. My SQL server is tf dev server, and so on. Right. I've saved my password in plain text, but you can actually save it in Key Vault and retrieve the value from Key Vault as well. And here in the plan, you can see it is actually showing me what resources will be created. It says, plus means create, so all of these will be created. Your resource group will be created. Your database will be created with all the values that you have specified and anything else that you have not mentioned as defaults. And you can see it doesn't know like when this was created because it has not been created. So once it creates, it knows the creation date. Similarly, it will know a lot of things which once it's created. So that's where the outputs come into play. So if you want to know like what is the source database ID, you can output that once the resource is created. And there's a SQL server that will be created and also a storage account that will be created here. Right. So I can review this plan and say, okay, 4 of them will be created. In my DevOps pipeline, I can have a step for my Terraform plan and have an approval after that. So whoever is approving needs to go and see like, okay, these are all the things that will be created. You're not breaking anything. And then finally approve and then run a Terraform apply. So I'll do a Terraform apply now by using the same file. So what this one will do is actually show the plan again. So as I've said, like Terraform apply includes a plan as a step implicitly. So it will create the plan, shows me the plan and says, okay, see 4 of them will be created. Do you want to proceed or not? I'll say yes. And I'll switch to my Azure portal. And when that is running, I mean, it'll take a few minutes to reflect in the portal because even though in the background, it has completed creation of the resource group, your portal doesn't reflect it immediately. There is a lag between when the resource is created and when your portal actually shows it. So wait for a couple of minutes and it should come back here. And the advantage with TF-vars is like you can have set of variables defined for each environment. So I have a dev TF-vars. I have a prod TF-vars, right? I can have a test UAT, how many number of TF-vars files I want, and I can save all of that predefined or define them as a config. And whichever environment I'm deploying to in my pipelines, I just call that specific TF-vars file. So this is like one massive main.tf file. There's no modules here, anything. If you want to add one more SQL database here, you have to write another resource block because you're not calling something else. And in here, we can see like if you're making a breaking change, that will reflect in your plan. So let's go ahead and refresh here, and there's tf dev RG, and inside it's still showing my storage account only. It should reflect my SQL server. Yes, my SQL server, and inside my SQL server, I should have a SQL database. Not yet. Refresh. As I said, there's a delay in the portal because here it's actually finished completing. Oh, there's an error. Invalid storage endpoint. All right, that's new. Okay, so it says there's an invalid storage endpoint. There was a dependency, but I think it's didn't pick up that correctly. Let me go ahead and see if it is SQL Server, SQL database. Thanks. No, not reply. I can run this again, which should be fine. It didn't pick the value correctly. And this demo was run like 30, 40 times before, never failed. And that's the beauty with code, right? So when it fails, you can see what the error is. You can see like, okay, 2 of them will be changed now. 2 of them will be added now because the SQL database was never created. And it didn't change. The SQL Server will be replaced because some reason the fully qualified domain name changes. That's weird. Let's do it. All right, while that is running, so now, I mean, in this case, if I want to add one more database, I need to copy this code and repeat that. So instead of doing that, why not I define that resource in a module and call that module how many number of times I want. So instead of creating all of this code again, I will just repeat the calling of that module. So that's where the module design comes into play. So in this case, we wanted like 3 different resources: storage account, SQL Server, and SQL DB. So in this case, what I'm going to do is actually create the resource group. But instead of creating the resources in my main.tf, I'm going to call the modules: the storage account module, SQL Server module, and SQL DB module. And in the module, it's again similar to what we have done with other code. You actually, in the SQL storage account, let's take example of storage account. So in the storage account, I'm actually specifying the provider and Terraform module blocks, and I'm fetching the information. So I'm not creating the resource group, I'm saying data. That means it will actually get the information about the resource group and then use that information inside my resource creation block. So in this case, I'm creating a storage account and passing in the resource group information from the data block. So until the resource group is created, it will not be able to see any information about the resource group. And it will fail if the resource group doesn't exist. So that's why I'm creating my resource group outside of that. And then I've got my SQL Server resource. Similar to my storage account, I again get the information about my resource group using the data block, and then create my SQL Server resource here. So in each module, I'm only creating the resource that is relevant in that module. So in this case, SQL DB, I'm creating only the SQL database, right? And here I'm getting the information about my SQL Server and storage account. Right. For resource group, I'm directly using the variable because I know like both of these depend on my resource group. So I can just pass in the resource group name as a variable. So this is simple split. I just split the code into modules, and then inside my main, I can call that module any number of times. I'll just say SQL DB and pass in the set of variables for my new SQL database. In this case, it's still repeating the module code, right? You still, whenever you want to call a module, you create a block to call the module. What if you want to loop it? What if you want to loop and create 3 SQL DBs at the same time, but you don't want to repeat that module? So that's where the loops come into play. So your complex variable structures, you can use complex variable structures to define as a list of or a map of objects or a list of objects, and use that variable to actually create multiple resources and keep that list dynamic, right? So you can create 3 or 4 or any number of databases that you want, and it will loop through that list and create each database. How do we achieve that? So I've got another module here called SQL DBs, the plural version, right? All I'm doing here is till this point, it's all the same. So I've provided the provider block, defined the provider block, Terraform block, getting the information about SQL Server and the storage account. Once I've got this, I am looping through this variable called SQL DBs. And when you look at the variables here, SQL DBs is nothing but a list of object and the object contains a mapping of your database edition and the service objective name. So it's like your database is basic B0, standard S0, and standard S1, something like that. So the way I've defined the variables, I'll show you one example here. So here test here. So I'm creating a SQL DBs, I'm passing a SQL DBs variable. I'm just telling TFDB1 is basic, TFDB2 is basic again, TFDB3 is standard. So now I've defined my variable. I'll just call this module SQL DBs once. And inside my module, I'm actually looping through that SQL DBs variable. And for each one of them, I'm creating a SQL database. Right? That's all I'm doing. I'm just looping through that variable list and passing those parameters for the index. So because I've got 3 variables in there, I'll create 3 SQL DBs. Even though it's one single module, it will now create three databases. For some reason, Azure is really slow today. It's still creating the old database. All right. I'll see if that's being done. Yeah. It's still creating the SQL Server. Great. It's not creating. Actually, it's the problem with Azure sometimes, because sometimes when you delete a resource, the definition of the resource still exists in the resource for some, in the port in Azure for some time, even though it's not shown in the portal. But in the background, sometimes when you drop a resource and try to create the resource with the same name, it says that resource already exists, but in the portal it doesn't show that resource. So it's sometimes an issue with the timing inside Azure. What I would say is, that's good. Now finished. All right, I'll leave that. I'll not try to create that one more time. What I'll do is I'll jump into my modules folder and then do a Terraform in it. It's just a bad day to run anything on Azure, I guess. So that's downloading the plugin here. And so here I've got the plugin downloaded. Now what I'll do is do a plan with my var file of test. So this will create a TF state file. While that is running, I can show you in all-in-one, it has created a TF state file. And this is the map that I was talking about. So when I created my resources, it will create a state file. And whenever it tries to create any resource or run your Terraform code again, it matches this Terraform state file to the resource that already exists and sees the differences. So in here, you can see it has actually got resources. It has got a resource group resource. It has got a storage account resource, and I do not expect to see a SQL Server because it was not created successfully. So that's my state file. So that's how Terraform maintains the state of your resources. Okay, here it says it will add 7 resources, and you can see that 7 resources is actually a resource group, a storage account, a SQL Server, and 4 databases. So 1 using this module SQL DB and 3 using the SQL DBs. So that's all the resources that it will create. So I'll just do an apply again. And fingers crossed this will run successfully. Otherwise, all my demos have failed today. Meanwhile, are there any questions?
Not at this stage.
Cool. All right. Let that one work out the plan. It should display what all resources will be created. Just say yes and let it run. So the learning curve with Terraform is really not very big. So when you want to deploy your resources, ARM template sometimes get very complex depending on number of resources that you are creating. Like with SQL DB, it's pretty much straightforward, right? So you've got a SQL Server and SQL DB. But when you think about a VM which is hosting SQL Server on it, when you create a VM, there are a lot many associated resources that you need to create, like your NIC, your disk, your OS disk, and the image that you are saving it, and any other networking components like your VNets, subnets, and all those things. So there's a lot more complexity around resources than just plain, clicking next and creating VM on Azure portal. And especially when you want to maintain your code as infrastructure as code, it gets even more complex with ARM templates. It's very hard to read the code as well with ARM templates because it's JSON. It's not very human readable, and with Terraform, the simplicity is in how you define your resources. It's very easy to read and it's very easy to understand what you're trying to achieve. You just need to provide meaningful names, of course, but when you look at the resource, by looking at the definition, I can clearly say, okay, I'm fetching the data about some resource. And here I can say I'm creating a SQL database, and I can see what all values I'm passing to it. So it's very easy to define or write your code using Terraform. So let's look at this one. So this one is running modules. So it is creating a storage account. So the storage account is created, and then it started creating my SQL Server. So once SQL Server is created, that's finished in 1 minute. And now it has started creating SQL Server database. And here you can see it has started creating them in parallel. So it didn't wait for one of them to finish. So it started creating a SQL DB. And then if you observe here, it's an array 0, 1, 2, and that's coming from the SQL DBs variable that I've passed, which has got the list like SQL DBs, right? So it's a length of 3 array. So it's 0, 1, 2. And all of them started creating at the same time because they don't have dependency between each other. They only got dependency on SQL Server. So they will wait till the SQL Server is finished. Once that is done, all the 4 databases start getting created at the same time. And now we see that they are all created. So no error this time. So that's good. So let's go into the portal here. Look at my resource groups. There's a test RG created, resource group created, and we can see there's a test server and 4 databases. And when you go in here, you can also see they are created based on the size that I've defined. So 3 of them were basic and 1 of them is standard. So it's very easy. All of this was done in like few hundreds or maybe less than 100 lines of code inside this module here, inside this modules folder here in this project. And it has created all the resources that I required, like storage account, SQL Server, 4 databases. I can even create like 20 databases here. I'll just need to add a list of 20 database variables here, and that's it. That's the only thing that I have to do. So it's very flexible in terms of how you can reuse your modules, how you can create this, and how quickly and fastly you can actually deploy this. That brings to the end of my demo, and all of this code that I've demonstrated here is actually available on GitHub. And if you have any questions, you can post in the Q&A panel. Otherwise, you can always reach me on my Twitter handle, ManuSQLGeek. I'm happy to answer any questions, whether it's Terraform related, Power BI related, Power Platform, or SQL Server. Anything that you can think about in the data platform space.
Thank you, Manu. So how long have you been using infrastructure of code with Terraform, and how did you get into it?
So when I joined Servian, so that's at the beginning of this year, I was introduced to Terraform. Before I've heard Terraform, I didn't even know that it's actually infrastructure as code. But once I started using it, I extensively use it now. So one of the recent projects where I've was standing up platform on Azure for a combination of resources, which is Data Lake, Azure Data Factory, Snowflake, and all other dependent components. So for data science, data IQ, VMs, and those kind of things. So there's a lot of things that was deployed as part of that project, and all of the platform was stood up using Terraform. We didn't use TerraGrunt there, but there was some other internal IP that we built, which was using Terraform and TerraGrunt. So the learning curve for me was it was very quick. So I've heard about it in Feb. I've started using it in March and delivered my first project in April, which stood up end-to-end platform in Azure for API management. So it doesn't really take anything to understand about the resources. It's more about how you stand up those resources on Azure.
And do you have, given that you've gone through that process very recently, do you have some good links that somebody might be able to use to go through that same process of quickly learning how this could be of assistance for them in their environment?
Good question. Most of my learning was directly by doing it, because when you start doing it, that's where you will see most value. To start with, to understanding the basic concepts, this session is actually a very good starting point, because you understand what basic building blocks are required for Terraform. And when you search for Terraform, and each resource and provider is different. So when you're creating, all you need to know is the syntax of the components here. So, and it's not even complex. So when you actually create a resource, you just specify a resource block, and then pass in what all values are required for that resource block. So it's very straightforward. The only complex thing that you need to learn is, like, if you are using a complex variable, how you work around loops, and that comes with practice. So even though you can see some examples, that comes with practice. So most of this data is available on the Terraform website. So when you search for Terraform, it takes you to the terraform.io, and this is where they have got some tutorials as well. These are very basic tutorials, but it will get you started on Azure. Like, this will help explain what's a provider block, how do you set up the environment, and how do you run it.
Very good. So another thing as a data platform professional, that having that in your arsenal could be a very good thing, because things always change.
Yeah, definitely. And you don't want to do ClickOps on Azure. It's very slow.
Well, if we don't have any other questions, I would like to say thank you to Manohar for coming along today and delivering this session. I'd like to thank all of our attendees. Once again, this session has been recorded and will be made available on the DBA Fundamentals archive site within the next week, once it's processed and put up. Stay tuned if you haven't already registered for our next session in 2 weeks' time. Between now and then, everybody stay safe. I look forward to seeing you all in 2 weeks' time. Thanks, everybody.
Thank you. Thank you all.